is this AI thing a bubble?
And it wrote me some SOPs that worked. Like first time, it was immediately useful. And now I have the way I evaluate a repo in my benchmark is an SOP.
Legislated a ban for social media access for children, for teens under age 16.
Where you can look at the data center from above and it looks just like a motherboard.
The whole point about Bitcoin, the reason why it has a power law is actually two power laws multiplied together. One is Metcalfe's law of networks, and the other is the power law growth in the adoption.
Welcome to the Orion X Download Podcast. Join Shaheen Khan, the Orion X analysts, and special guests as they discuss and simplify the big ideas in technology that are changing the world. Thank you for being with us.
Welcome to another session of the Orion X Analyst Roundtable. I have to mention every time that it spells art because we do art and science of all the buzzwords that are out there and the technology trends. With me as before is Adrian Cockcroft, Chris Krull, Stephen Perno. How are you, gentlemen?
Fine, thank you.
Doing well.
Right, we're covering all the major time zones today, with scattered all around the world. So without further ado, which is what we usually do, Adrian, you've been working on AI-aided coding, vibe coding, whatever the terminology is right now, and it seems to be making significant progress. So please catch us up.
Okay, so since the last time we spoke, I gave a talk at QCon San Francisco called Managing a Swarm of AI Agents for Fun and Profit. And it went very well. I was one of the highest audience feedback ratings that I've ever seen, like 99% positive rating. One person thought it was average. So, I got to go find that one person and find out what that one person didn't like about it. But it was... but I think I pushed a bunch of buttons that people like. So it was sort of very practical and but also sort of leading edge, and then it sort of tied into a lot of people's interests. So that was a good session. During that conference, Google and OpenAI released new versions of their coding agents, and later that week, Anthropic released a new version of Claude, which is, and benchmarking that new version of Claude, it did the same task in about a quarter of the time and a quarter of the number of tokens, which is roughly what they were saying. It's the speed up is not just a few percent. It's like they're collapsing the amount of thinking required to get an outcome. And it just seems to be better. So that's just like an average month in the world of AI coding. The tooling is getting better faster than you can keep up. Coming out of that, I wrote a blog post write up on that. And I also created a benchmark as a organization on GitHub called Brazil-Bench, where I've put a standard task, which is to teach an AI agent about Brazilian football by feeding a knowledge graph into it and then being able to ask it questions. So that's the task. And then I'm running that task against multiple different tooling, and you can it's a repeatable task, basically. So that's the idea. So I've been playing around with that. I need to do a little bit more on that, but that's been most of the sort of coding things I've done in the last month. And it was an interesting conference. Met a whole bunch of good people, and it's a good conference for developers to sort of track where things are happening in this space.
Do you characterize this as a major trend?
Yes, the rate of change isn't slowing down. We're now seeing second order effects because the coding agents are now good enough that they're actually able to build new things really quickly. So there are people like Reuven Cohen came out with yet another new thing in the last few weeks, which seems really useful. It's a replacement for the PG Vector plugin for Postgres, but it's called it Rub Vector, and he's written it in Rust, and it's off there. And the next thing I have to do is go play with that. It's basically a graph neural network running on top of a database, or it sort of replaces the graph database side of things. So it's just, a brand new thing turns up that looks useful because he was able to write it in a few days. Normally that would have been a much bigger development. So we're seeing that thing happen, and we're seeing more the tooling getting faster and better pretty quickly. So the problem with that, which is sort of part of the subject of the talk, the fun and profit part was you have to be playing with this and exploring and experimenting on projects that aren't production, whatever you call non-production, like pet projects. That's the fun part. You've got to have some things that you can play with to try and figure out what works and what doesn't work, because the boundary of what is working is moving back really quickly. So you have to be experimenting on the other side of that boundary with things that may not work. And once you find something that does work as sort of repeatable pattern, then you go to the for-profit bit. You can actually use it to go build something, right? So without that playing around and spending a good amount of time experimenting, you're not going you're going to get stuck in a dead end. You're not going to be tracking what's happening in this space. So that's sort of the way I was sort of trying to push people
So
in that
one
direction.
one observation I've had is that there is a how-to to doing AI. That simply because it's AI, the expectation that it is easy to use and it's just going to work doesn't work out. You need to know how to do it. So the answer to the question of, are you telling me I don't know how to use AI, could very well be yes. You kind of do need to know how to do it. Do you see that? Is that valid?
I think you need to know how to manage developers, is the skill set that I'm finding is the one that really drives successful outcomes. Because the human developers do most of the stupid things that the AI agents do as well. But so you have processes wrapped around that that make you have a good outcome. And that's basically what it looks like.
Chris, you were going to
Kristen
say?
Scott.
Yeah, so, Adrian, you bring up a good point that people need to be playing with these things all the time, right? Because of that, the rapid rate of change. Do you see that rate of change as being a barrier in moving into production or getting utility out of AI with what people are trying to do in the enterprise, for example?
Yeah, we've mentioned that before. I call it enterprise indigestion. The rate of change is too high for enterprises to absorb and deploy new things. And the people that are able to keep up with the rate of change here are startups and the whatever scaled digital natives, or whatever you call the sort of Netflixes of this world, who are actually deploying these things rapidly and figuring out platforms for deploying them successfully and
So
figuring out where it works,
Yeah, there's that catch-22 though of and maybe the big guys just get pushed to the sideline by these disruptors coming along, the smaller, more agile organizations. But there's that catch-22 of you can't stay away from it, but on the other hand, what you're deploying on a larger scale is immediately out of date. So it's an interesting thing to follow, especially as we see the business models, right? Anthropic pushing more toward enterprise than consumer. ChatGPT doing a bit of both kind of thing. I'm not sure where Gemini lands, but
Part of what you said is that the skill set required is managing developers, not being a developer. That points to this tool essentially replacing developers. And if you are a developer, you're not going to mingle well with it. And if you are a manager, then it's easier because you just replace them all with the agents. Does that work, or do you still need actual developer skill set profile in the organization somewhere?
I think you do. And there's an analogy that I have in my talk as well, which is that if you go back to cloud, we had what I'd call a ticket and click it operations person. We sent them a ticket and they click buttons in VMware to make something happen, or they go and install a thing in the data center. And that was the operations cycle. And nowadays we have like DevOps and SREs, and some of them are the same people that retrained themselves. So they know how operations works. They have probably, physically carried a machine into a data center at some point in their past, but they don't need to do that now. They just need to understand what's involved in that. So you have a enough memory to have like the architecture of the solution in your head, but the operation of that is now happening with automation in cloud. So we called that no-ops for a while, but some people didn't like the idea of the word no-ops. So I said, well, maybe what we have coming up now is no devs, because I have developers now on call. If I want 5 developers, I type something into Claude Code and 5 developers appear and they run for half an hour and they're done, right? I don't have to go and hire 5 developers.
Developer as a service.
Yeah, the developer capacity is available on demand. Now the question is, can you manage that to an outcome, given that they're effectively off the street developers without a lot of context on your project? So then the question is, can you feed them the context that means they come in now and they are productive? but the onboarding process effectively of a new hire has to be compressed to the point where that is automated. So we're just automating that part of the flow. And then the question is, do you get a good output from that? And there's parts of the problem solution space that are quite reliable, like building a relatively simple Python script. I'm getting 100%. It just works. If it doesn't work, then I'm surprised. And then there's other things that are more complex, which are sort of beyond the boundary of what currently works. And you can, there's all different, everything in between. So that boundary,
Right.
as it moves back. So then the thing is, can I automate the management of these agents? And I call that no man, if you like, right? It's because if I can automate the low-level management away, I don't need a line manager. I have a management agent that is watching over these agents and making them do the right thing. So I'm experimenting a little bit with some tools around that. So what Amazon came out with was an SOP tooling for agents that's basically standard operating procedures, and it's a framework for building these. I pointed Claude at the blog post about it. It read that. It went, oh, I see how this works. And it wrote me some SOPs that worked. Like first time, it was immediately useful. And now I have the way I evaluate a repo in my benchmark is an SOP. Then it generates the same output. And I've used it on 3-4 repos now. And it comes out with the same structured output because the SOP tells it what the structure should be. So now you've got repeatable tasks, but still with the ability to innovate within that repetition based on what it sees, right? So the innovation isn't a fixed recipe, but it's guided by this document basically says that you must do this and you should do this and you should think about these things. Anyway, it's
Very well.
that
Excellent.
came out in the last month, the Strands SOP AWS toolkit. I tried using it. It worked first time. That's kind of the world we're living in now.
Amazing. Yeah, absolutely. So while all of this big trend is happening, there's also increasing conversation anyway, if not actual worry about, is this AI thing a bubble? Are we just getting too passionate about this? What's your take on that?
We talked about this last month where I saw there was some things written by Polkadrowski, and I think those were amplified into basically along the same lines, but with a bit more detail around them by Ed Zitron in a blog post that's making the rounds right now. And it's basically saying, is NVIDIA an Enron? And like, maybe they aren't an Enron, but what are they? And what are they doing that is dodgy? And there's a bunch of things in there that ask a few questions, and most of it's okay. But the thing that I picked up from it that was the big question was, NVIDIA says that it's shipped a certain number of Blackwell chips, Blackwell GPUs. But if you say that each of those should be running somewhere, then they would be consuming, say, 2 kilowatts per chip to be running effectively, because it's over a kilowatt just for one Blackwell, plus the rest of the machine is the rest of the. So it's kind of the order of 2 kilowatts per Blackwell. And he says that you go looking at the deployed data center capacity of everybody and the energy supply. He says he can't find the energy that will be needed to actually be running that number of Blackwells. So then he postulates that maybe they're just sitting in a warehouse somewhere and they've been bought because somebody said, I need to buy all these, but not actually deployed yet because the data center capacity doesn't exist to deploy them yet, and the energy required isn't there yet. So that was a new thought, that maybe there's some actual overbuying. NVIDIA has sold the chips to somebody, but they're just sitting somewhere. They're not actually out in the world. And of course, Rubin's coming out, so those Blackwells will be obsolete maybe before they're turned on even. I don't know if that's a thing, or what you guys think about that. Is that credible, or does it make sense?
I think it makes sense. I wonder whether, did he give any indication whether it was more data center build out per se, or just even worse, the availability of electricity to power the data centers?
I think he was looking at the power consumption as the main driver and just trying to find where that could possibly be, and just not finding the major supply, the people who have enough capacity deployed to take a water-cooled rack is a relatively limited number of places to look. And he was looking at what he could find about the capacity there. So I think it's a good question. I think over the coming months it'll become clearer what's really happening there.
Yeah.
But
So I
that's one of
find it
those things that sort
unlikely.
of but it's kind of keeping the bubble inflated would be this sort of keeping the price high. And if there was actually a glut in the market, then the price would come down, right? So that's sort of the thing that tends to blow up a glut is when supply actually starts to exceed or meet demand, right? So the
Right.
question is, can
Right.
demand stay ahead of supply enough to keep the price high?
Right. I guess the worry is whether there's a glut of GPUs suddenly, and then everybody has as many as they want, and then the price drops, etc. And that would be the deflation of whatever we would then call bubble. But I see this as unlikely. I believe it is highly unlikely that an organization as kind of rigorously managed as these big cloud providers are would sort of put themselves in a position of having such magnitude of overbuying and warehousing them and not actually selling them on the open market to get rid of them and just like sit on them long enough for this to be an issue. I feel like Nvidia is showing the receipts. They've got the revenue. People are paying them. That money is real. The chips that are getting shipped are real. The roadmap is real. Like you said, Rubin is coming. All of this stuff is going to be past generation. They're still useful, but if you're a big player with enough wherewithal to hoard them, you are also the kind who's going to want the latest. So it doesn't hang together with me. I feel like there's obviously a lot of passion and what is the right word, exuberance in the market. But I think if we get anything at all, it might just be like a little bit of a hiccup rather than any. This does not look like a bubble to me.
So clearly we have a refresh cycle on the horizon. That'll help maintain some helium in the balloon. One of the things that occurs to me is that the lens that we're viewing quote unquote AI through is too narrow. I mean, yes, you can point to NVIDIA as helping prop up whatever slice of market you want to talk about. But the real action, and all of us come from hardware backgrounds, we know that the real action is how this stuff gets used. And so those trickle down effects in the software and agent and et cetera world is really where AI is going to bear a lot of fruit in the coming years. So I don't know that we take a holistic enough view of AI when we talk about a bubble.
There's been another signal here. I'm not sure exactly how to interpret it. That there's now a DRAM shortage, and the news was that is it Micron is shutting down Crucial because they don't have enough supply to supply people, consumers.
Yeah, and
So
SK
they're all
Hynix
and they're going into.
The way I understood it, and I did not look too deeply, was that they were redirecting their capacity towards servers, and that the power issue has led to server providers and NVIDIAs of the world to look at cell phone technology memory because it is way lower power. And if you redirect those to servers, you're now suddenly got a lot higher margin capacity versus lower margin capacity. That's where I'm going to take it. And there's a big set of orders that are coming for it. The price is going up, and that's why we have the memory shortage. The other thing I've seen is that because everybody's kind of seen that they have to wait a long time to receive what they order, that they're placing orders in advance of themselves needing it, and that's going upstream. It's moved past chips to memory to motherboards to actual systems. So they're going upstream to lock up capacity for the next 18 months, and then they're kind of sitting pretty, and that is also a good competitive move if you have the wherewithal to do it. But it all rests on your confidence that the demand is going to be there, right?
Yeah.
Well, and
And then the
we're
other
also
side
seeing
of this, sorry.
Yeah.
Well, I'm sorry, but we're seeing also a technology shift taking place, right? So we've got DDR5 and LPDDR5X, et cetera, coming
That's
online.
it. LPDDR
And
is what I.
HBM, right? So that speaks a little bit toward your point about moving toward server and higher up the tree types of implementations. So I think we're seeing that at the same time that people are trying to figure out how to build what they're trying to build.
Okay, so as an indication of it not being a bubble, everybody's doing their own AI chip now. Anybody who can is. Obviously, AWS, Google, Microsoft, Meta, and Marvell has parlayed that into a big growth business as it co-designs with these guys and adds all the blanks that they might have in terms of networking, and NVIDIA has been more liberal in licensing their NVLink technology to accelerate that. So, uh, Adrian, you tracked reInvent as you normally do, the AWS conference, and they talked about their next generation AI chips and CPUs as well. Do you want to say a little bit about that?
Yeah, just briefly. I didn't go in person this year, but I watched the keynote, the main keynotes, where they announced most of what they were doing. And the takeaways from that, their own chip is called Tranium, and the technology that they've targeted up to now has been one step behind NVIDIA, so they're not competing directly with NVIDIA for capacity and aiming at something that looks like about half the performance per chip, but less than half the power and less than half the cost. So what they can say is overall you use twice as many chips, but it costs less and it uses less power. So that's been their sort of strategy so that they don't get into a sort of a competing for the same wafer capacity kind of issue. So that was Tranium 2, Tranium 3 seem to be following that path. And the outcome from that is that they do have a very large capacity up and running. They were talking about that. The uh, the main customer they talk about is Anthropic. So a fair amount of the capacity that's being used to run Claude is running on this on Tranium, and they're learning how to roll this out in very high capacity. They say they have more gigawatts of this than anyone else, but whatever. That's They then announced that Tranium 3 is now shipping. They had previously announced that, I think, a year ago. And they announced the specs for Tranium 4, which is in a more aggressive feature size. They're going for a more aggressive process and more capacity. And it looks, so then again, I think they're following the same strategy. But the thing that was new that I hadn't seen before was they licensed NVLink from NVIDIA, so that you'll be able to use the Tranium 4 in the same environment, the same sort of circuit level environment that the Blackwell and Rubin chips are using. So it becomes part of the NVIDIA chip level ecosystem, because NVLink is how NVIDIA glues together all its chips. I think that's a pretty significant change, because I hadn't seen NVIDIA licensing that previously, but there was definitely talk a year ago that AWS was going to figure out how to get more closely integrated with NVIDIA. So that was sort of the pre-announcement, if you like. And this was the actual, okay, we've licensed this and it's in our next gen chip.
They had done that for their B10 chip, which is in their little desktop Spark box, if I remember correctly, to MediaTek, was it? And so I think what they're doing with NVLink is pretty significant strategically, because while they're licensing it, which is okay, that's kind of new, they also announced something called NVQ-Link for connectivity between a traditional classical computer and a quantum computer with GPUs inside that would be used for running error correcting code, which can be very computationally demanding and by definition needs to be real time. And like putting that inside and positioning it as a connectivity thing rather than an error correcting thing was very interesting. The idea of becoming more of a standard in the fabric space is quite interesting.
There was a lot more announcements from AWS, mostly in the software stack and various things they're doing with partners. So they're diving in and trying to get AI to be digestible by enterprises is probably the best way of looking at that.
Similar to Trainium, obviously Google was the first to do their own AI chip called TPU for Tensor Processing Unit, and they're in their 7th generation of that. The last one that they did, called Ironwood, also comes in its own rack. And there was rumors that some of the neo clouds as well as Meta were in conversations with Google to get access to those systems. Sort of the implication was like on-prem. It's not clear whether that's the case or not. For the neoclouds, of course, it'd be on-prem for neoclouds. But then my take is that the neocloud emerging as a customer class really is what the news is there, is that Google does not need to become a traditional server provider. It can just be a new cloud provider. Like you need a data center here, data center as a system, like I've been saying for the past 20 years, right? We had slides of that when we were at Sun, where you can look at the data center from above and it looks just like a motherboard, right? I mean, everything is going to eventually look like a motherboard. I think that's another rule that we can talk about. But anyway, that became pretty interesting. And people were wondering, is this the beginning of real competition for NVIDIA? I don't think so. I think it's been like carrying on exactly the way things have been. NVIDIA has always had competition. Certainly the cloud providers doing their own AI chip consumes a bunch of AI workload that otherwise would have gone to mostly NVIDIA and AMD and such. And in the meantime, AMD is becoming stronger and stronger. They got a deal going with OpenAI, so they got that endorsement. I mean, if you're doing AI, OpenAI and NVIDIA are as good an endorsement as you can get, right? So Intel got it through NVIDIA and AMD got it through OpenAI.
Google is also renting data centers from CoreWeave that have NVIDIA chips in to bolster their
Right.
data center capacity. So everyone is after everything everywhere, and they're all trying to build it up. Again, going back to Ed Zitron and Paul Kudrowski's case, the revenue needed to sustain the level of build out right now is not feasible. From like there is where does people would have to be spending a ridiculous amount of money in a few years' time to fund what people have on their books, which basically, when that happens in a market, what it means is that when the bubble bursts, some amount of that just doesn't happen, right? There's basically overbooking of revenue and capacity because people are booking more than they really need because they don't know, right? So that it collapses down to something sustainable at some point. And
Right.
like with every bubble, you can say that you can point at a bubble, but you can't say when it's going to burst, right? That's the thing. You can't time this. It might be tomorrow, it might be in 5 years, but you can point at a bubble and say it has to burst some point.
Well, I think that reduces the growth rate, but it is not going to be a problem primarily because the stuff isn't evergreen. The stuff does get aged and it does become old as much as you can use them and maybe you do use them, but the power and cooling and all that is getting better and better. So I think that will, I mean, in the scenario where a whole lot of people, a whole lot of companies who are buying or using GPUs uh, can't sustain it because they're not profitable and their funding source demands that now. So I think even if they all stop, that capacity isn't going to just turn over.
Here's the counter argument to that. If you say that the current generation versus a generation in 3 years' time, 2 or 3 years' time, is, say, 4 times more powerful at the same power, right? It's sort of
Yeah,
doubling per year or something like that. And you're currently depreciating your GPUs over 6 years, which is the common hardware is depreciated over 6 years. That's what's going on the books at the hyperscalers.
hmm
In a few years' time, you are power limited. It doesn't make sense to be running an old chip that
exactly,
consumes that is it makes sense to just shut it down, turn it off, get rid of it, and put in the new one. It doesn't make sense to run the old ones because they consume too much energy and you're energy limited. So there's
exactly,
a built-in thing which means that over every 2 or 3 years it's actually makes sense to just get rid of the old stuff completely. And so when you're depreciating over 6 years, there's no useful value of it. You need to be depreciating it over 3 years, and even that's probably a stretch, right? It's not going to be
that's right,
economic to run
that's
these
right.
things. So that's when you're power limited, that drives that behavior. And so the question is how quickly we can end up not being power limited or what other constraints you have.
And this is true across the board. Even in embedded edge devices, you're always power limited. So the new guy is going to win. Let's move to another topic, and that was what was being live streamed by the BBC last night when uh,
Yeah.
Australia's social media ban went into effect. And Chris, you were tracking that. What is your take?
Yeah. So first, let's talk about what it is. So, effective December 10th, which we're some of our time zones were December 10th, and it's yesterday in Australia. But so they've legislated a ban for social media access for children, for teens under age 16, and they're putting the onus of enforcement on 10 named companies. Now, this is a dynamic list that they've said it's a dynamic list, but it's, the usual suspects, right? We're talking about TikTok, Facebook, Instagram, Threads, Twitter or X, YouTube, Reddit, Kick, Twitch, and Snapchat. Those are the named platforms that need to enforce this ban. Now, they also explicitly excluded platforms such as Discord, Google Classroom, Lego Play, LinkedIn, which I'm sure big deal, but I mentioned Discord, WhatsApp, YouTube Kids, Pinterest, Roblox, Lemonade, which came out a few years ago as an alternative to TikTok when the TikTok ban was a live thing. It's a whole other topic. Steam Chat, Messenger. So they've segregated the social platforms, going after the big guys, and again, the onus is on the social media companies, and how are they doing this? Some are being a little hazy on how they're determining what the age is. Sometimes it's self-reported, or it's a combination of self-reporting with behavioral characteristics. There's a company out there called K-ID, which has built their business around validating the ages of account holders. So the people affected could download their content from these platforms before their access is cut off. The live stream on BBC, which I was surprised to discover, said that there are a lot of people still had access. The actual shutdown is trickling out, and the platforms will, I think, almost every case, freeze the account until that person is determined to turn age 16, and no new accounts would be able to be formed. So that's the essence of what's taken place. And, I've been thinking about this topic for a while because here, a lot of people have been talking about the damaging effects of social media and the addiction, right? And as we were joking before we came on live or recording, this addiction and these effects are not limited to teenagers and tweens and younger kids, but the focus has been on the harmful effects on children. And so countries such as Australia, which is being closely watched by other countries, they don't run into First Amendment issues because they don't have a First Amendment. So it's a little easier for them to legislate that sort of thing. These things have tried to come up here in the States, but First Amendment basically prevents the state or the federal government from legislating access. But there's nothing preventing companies from themselves self-imposing age limits. But at the end of the day, the companies are profit motivated, and advertising and addiction drives their top line and bottom line.
And it's an important demographic. So they have entire departments focused on caring and feeding of that particular market segment and keeping them engaged.
Yeah, absolutely. And in the adult world, we hear about terms like social media detox and those kinds of things. And people talk about the benefits of unplugging and so forth.
Fasting.
And, fasting. Touch grass, right? So, my take on this is that I think there should be some form of age gating. I think that companies should take on more responsibility in monitoring who has access and so forth. But it's not totally reliant on the companies themselves. There's a social aspect. There's various schools and school districts that have instituted no phone policies, in part because of the social media access during the day. But it's at the end of the day, I think it's down to parents and schools and other aspects of society to help create a cultural norm where social media is pushed a little bit to the background. I don't know, is the horse out of the barn? Perhaps, but I think it's a challenge. But at the end of the day, we should be paying attention to the damaging effects. And Steve, you want to chime in here?
Well, I find it interesting that AI is not on the list. I don't know if there were any comments about that in any of this. I haven't seen any commentary about AI in this regard to this limitation. But we know that AI is starting to manifest some dangerous behaviors for some teenagers who are, befriending it
Right.
in the wrong way.
Yeah.
And so it's quite notable as an omission. And I would just wonder whether they're starting to look at that as well.
So people are thinking about it, talking about it, and yes, there have been cases where AI gets blamed for suicides, actually.
Right.
So that's clearly a dangerous thing. My perspective on this is that the legislation and talks of these kinds of legislation comes a little bit more around peer pressure and groups and so forth, and the naming and shaming and the peer pressure to belong. I think that's sort of the first order of business. And these kinds of things have been talked about for years. So that conversation is further along than the presence of AI in our culture and in our lives. So I wouldn't be surprised if AI does get pulled into it, but yeah, that's more on an individual level.
There's also the business value of knowing your customer, and the age verification is valuable. So there's pressure
Yes.
from the social media companies that want to age. It's valuable to them to have people that are verified, because one way of doing it is showing you have a credit card in your name, for example.
Right.
So now you've got a billable mechanism, right? But that proves that you're old enough to have a credit card. And there's a bunch of things like that. But I did hear one person who was on X get a message saying they're asking me to prove my age, and says, well, this X account was a Twitter account that I opened over 20 years ago, so I obviously am over 20 years old, right? Why are you asking me to prove that I'm over 16 on a 20 plus year old Twitter account? So.
Well, and that does lead into, how effective can this sort of ban be? And kids are going to find their ways around it. I mean, there have been age limits on drinking, and for example, and we all know we were teenagers once, and we know that any motivated youngster is going to find their way to doing what they want. But I think this,
But it does reduce it.
Yeah, this has given parents a tool, for example. Hey,
I think you're just training kids to use VPNs, and the ones that don't have parents helping them do that are going to end up with the very scammy VPNs, which are much worse than the social media companies. The free VPNs, nothing's free, right? So there are some. I just think that's all. And then if AI isn't banned, you just go and ask ChatGPT how to set up a VPN and find me a social media service that is not banned, that no one's heard of, and they all end up on Mastodon or something.
Exactly.
Exactly.
So the interesting thing to me about this is the impact of technology on all aspects of life, in this case, parenting. Because the discussion that ensues is this something that you regulate, or is this something that is the responsibility of the parents? And if you don't like it, then do something about it. So that's kind of one side of the discussion. The other side is that if I'm talking about weaponized information and it is an actual weapon, I cannot guard against a weapon. Both sides need to be regulated, in other words. But it's an indication of how technology is creeping into all aspects of life. And in this case, I consider it an interesting experiment that Australia is running. And let's see how this pans out, since they're doing it anyway. Regardless of which side you are not there to vote for it. And watching what happens would be interesting. I do expect that it will have an impact. It will reduce it. Those who really want to can obviously find their way, but many won't. And deciding what to regulate for who and how is tricky anyway.
Sure.
And it's a burden that you're picking up for society. So you want to be careful about it. But when you need it, then you need it.
Well, and it's a pendulum, right? I mean,
Yeah.
We'll move from trends of regulation, more regulation to less regulation and back and forth.
Right.
So
So
we'll
let's switch to crypto. Dr. Perno, what's up with Bitcoin? It dropped in prices, and for some people, that was a surprise. Was it?
Well, I think it was a surprise for a lot of people. Within the community, the expectation has been that there would be a big bubble in 2025. And it's because the community, the majority of the community, I would say, has believed in this idea of a 4-year cycle tied to the halvings. So the halvings happened every 4 years, slightly earlier each year because the chain runs a bit faster than 10 minutes per block on average, but the difficulty adjustment is always pushing it back towards 10 minutes. Every fortnight, it's adjusted. Every 2016 blocks, to be precise. So there was a halving in 2012, 2016, 2020, and 2024, and the peaks in the past kind of looked like they were happening a year after the halvings because there were peaks in 2013 and 2017. But in fact, this whole kind of myth, that I call it a myth, others don't accept it yet, that it's a myth, of a 4-year cycle, always conveniently ignored the very large bubble that happened in 2011, well over a year before the first halving, when Bitcoin had an age of about 2.4 years, well before 4 years had come around. They just threw that away and said, let's look at these other two. And you have a situation where you've got like 3 events. You have bubble in 2013, 2017, 2021. It's not very good statistics to, then make an assumption that these things are on a 4-year linear cycle. But the mythology was reinforced by the fact that you have presidential elections in those same years. And in fact, we saw a big run up with the presidential election in the US around the time because the Trump administration coming in was more pro-crypto and pro-Bitcoin. And so there was a bubble, but then it didn't materialize in the rest of 2025. Instead, we had fairly kind of steady progress. So if you look at things very broadly, they've adhered to this long-term power law. And that power law is quite steep. It's faster than the 5th power of the age of Bitcoin, approaching the 6th power. It's about 5.7, basically. So you put things on a log-log plot, it's a straight line. So that holds up. But what makes it difficult for people to be in the market sometimes is that the bubbles have been very, very strong. The volatility has been very high. This has been coming down. Well, I was worrying about this issue all throughout this year, whether we were going to have a bubble in 2025. I did a lot of analysis on the bubbles in the past. I saw that the energy in the bubbles was coming down roughly with the reciprocal of the age of Bitcoin. And I separated out the behavior in the core power law and in the bubbles themselves, found that the core power law's volatility is pretty constant, actually, and that the volatility was much higher and then coming down in the bubbles. But in the last really couple of weeks, I've redone an analysis of the bubble timings, including the 2011 bubble, and then with the realization that we have had no bubble in 2025. And then what you find out is indeed it's not a linear cycle. It's a log periodic kind of a cycle is what it appears to be. And, in order to prove that, we'll need to see the next one happen on that sort of log periodic schedule. But if I tell you that the bubbles occurred at age 2.4 and then 4.9 and then age 9, and that the next fundamental mode bubble based on the Fourier analysis that yields this log periodic parameter would be at age 18.4. That's into 2027, approaching the mid-year of 2027. And I've done it both for Bitcoin versus dollar and Bitcoin versus gold, where I first kind of discovered this. And I will say it's a rediscovery because long ago, Giovanni, who was the first one to find the general power law nature, did some of this log periodic analysis as well. And actually, his forecast for a next bubble would have been, next year, that there would not be a bubble in 2025. We've got 6 more years data to analyze, and both with the Fourier analysis method and with a wavelet analysis method, and both based on dollar and gold, you get this same result, which is this logarithmic lambda parameter is called, but it's a multiplicative parameter roughly between successive bubbles of a little over a factor of 2. It's 2.07. The 2021 bubble is a little bit of an anomaly because it was double bubble and weaker. And it turns out, though, you can explain it as the first harmonic of the fundamental mode of this thing. And this is expected if you have continuous scale invariant behavior, which the power law is the representation of, if it has discrete things that it impacts or that impact it. So as the market cap of Bitcoin rises to higher and higher levels, and it's risen by more than 7 orders of magnitude, it gets whole new classes of investors. You started out with the cypherpunks, and then you got retail, and then you got the first exchanges, and then you get the first hedge funds, and it's gone up the capital stack to where now it's dominated by institutional investors. They're the net buyer through the ETFs and through the treasury companies in particular. So those are retail buyers underneath because they're the shareholders of Strategy, which used to be MicroStrategy, and they're the shareholders of the largest Bitcoin ETFs. But, this has dominated the net buying, and it's rising as the fourth power of age. So it's clearly the big driver. Mm-hmm. And as this happens, the capital pools are deeper. You expect the volatility to go down, and you've seen that happen. But it also imposes these sort of, when you get to these discrete tiers, and the ones that lay ahead of it, if it's going to continue to be successful, would be the very largest companies like the Mag 7 companies, and then governments, sovereigns. And we see sovereign wealth funds already. So all of this sort of hierarchical capital structure in the fiat world that's coming into the Bitcoin space is what imposes this kind of log periodic nature. And this is a phenomenon that's seen, in other disciplines. So it's, in a sense, not surprising at all. So that's why we didn't have a bubble in 2025 is my belief. We had a big down move of about 30% since the peak in early October. It's come back a little bit. We dropped into the 80s. It held in the 80,000 range and has moved back up into the 90s. The sudden drop that we had within the last couple of weeks, there's some conspiracy theories around that related to JP Morgan and Morgan Stanley, and Morgan Stanley are the keepers of the MSCI index, and they're talking about excluding the Bitcoin treasury companies like Strategy from that index. Saylor's gone in to talk to them. It's not a decision yet, but I think the decision's going to be made in January, middle of January. So we'll see what happens there. But it's not huge. It doesn't prevent them from being in the S&P 500 index at some point in the future, for example. It's just that Morgan Stanley has a set of indices also they use in the world. And JP Morgan introduced a structured Bitcoin product that basically caps how much you can lose and how much you can make for people who are more risk averse. And they did that right after this drop happened. So that's why there's been some conspiracy talk around that. Any questions before I segue into our latest Crypto Super Report?
If you don't say that 2025 was a bubble, how do you characterize it? Because you look at early in the year, we were, low to mid 80s, I want to say. Mm-hmm. Let's come back to mid 90-ish with a big spike in there. So if you extrapolate that out, and past performance, no indicator of future performance kind of thing. But do you, I mean, based on what you've said, you're implying or outright saying that 2027 is probably the next bubble. And so that implies that we're going to see a growth of, or a value of Bitcoin well beyond the 126-ish that it hit earlier this year. How do you characterize what we've experienced in 2025 when it looks like a bubble on the chart?
Well, it all depends on what kind of chart you draw and understanding how much volatility there is, because the volatility is about a factor of 1.5, a little more than that. And that's the 1 sigma standard deviation. So, if fair price on a power law is 100,000, if you go to 150, you're still only 1 sigma away. And if you drop to 70,000, right? So you really have to look at things in logarithmic terms in order, to decide. But I would characterize it as waves. We've had these waves and we've stayed close to the power law, and everything's intact as far as the power law. Yeah, we're a little bit below it, but we're less than half a sigma, half a standard deviation below it. Fair value now is about 110,000, and today we're about 92, and it's just not huge relative to Bitcoin's volatility. Now, if we do have a real bubble, and these bubbles tend to have like sharp peak blow-off tops, and if it happens, say, around mid-year 2027, as predicted both by the analysis versus gold and the dollar, you could run up to 350,000 or more, and that would be in a kind of a blow-off top. But you would expect prices to pick up considerably, during 2026, particularly late in 2026. And just to get the sort of wave motion that you get, not including the blow-off top, it would not be unusual to see the 150 to 200,000 by the end of next year. But a lot of people thought that was going to happen this year, and there are all kinds of forecasts that people were putting out. Actually, Tom Lee nailed it. He said 126,000, but all the other forecasts were higher. They were, many of them were up or above 300,000. I never thought that was in the cards. I thought we wouldn't reach 200,000, but we could do that next year if this, next fundamental mode is a reality.
Okay, thanks.
Well, I knew the science of bubbles was a very complicated one in real life. It looks like it's pretty complicated for markets as well. It requires FFTs. That already tells you.
Yes, and there are these things called log periodic power law bubbles, and they have 7 parameters in it. So,
but I remember, Adrian, you were using FFTs for capacity planning analysis more than a decade ago. I remember a talk you gave that had
Yeah, I mean, anything periodic at FFTs is how you analyze the frequency spectrum. It's just you're just operating on frequencies instead of over time, right? That's all. I did Fourier transfer as part of my physics degree a long time ago, and I built things on it, and just
that's
another
right.
tool.
That's right.
Yeah. But when you're looking at something that's periodic, that's where you'll end up.
Even if the period is 1.
Well, if it's a period's 1, then if it's repeating continuously, you can just use sine waves or something, right? It's a constant frequency, right?
But it's further evidence that life is. Go ahead.
Yeah, I mean, if you're looking at distributions of things and how they're varying, then yeah. And then logging, every time I see something that's where the elements are multiplied together to have an effect, you take logarithms and then things become added together and you can separate out effects that you can't. So there's a whole bunch of tricks that are used to make analysis tractable, right?
Easier,
and this is sort of the physicist toolkit. Is like, take logs of it, take FFTs of it. Okay, does it look simple yet? Okay, and then you do the analysis and take your exponents and turn it to an inverse FFT, and you've got this complicated looking thing. But underlying is a set of modes and ratios. So that's, I always go back to the book by from the Santa Fe Institute on scale by, is it Jeffrey
Jeffrey
West?
West. Yeah.
Yeah, there's a lot of good. If you want to see some good examples there,
That's a
they
good
take a
book.
lot of physical and biological and phenomena and economic phenomena, and they reduce them to straight lines with very
Well,
very
the whole
characteristic.
point about Bitcoin, the reason why it has a power law is actually two power laws multiplied together. One is Metcalfe's law of networks, and the other is the power law growth in the adoption. So the first order, Metcalfe's law says the square of the number of users, which you can approximate with the number of wallets holding Bitcoin. And historically, that's gone up as the Q. So the product of those is 6, right? When you put the two of those together, you've got a square of a cube is 6. So it's gone up is nearly the 6th power in price and in market cap.
Yeah, excellent. I'm really delighted with all the scientific approach that you and Giovanni and team are taking towards Bitcoin. So let's wrap with a quick update on SC25 and RISC-V Summit and Q2B, the conferences that we normally go to. Adrian was doing other conferences, and Chris, you and I did it last time. So this time I was doing it. So SC25 attendance slightly below what it was the previous year. Atlanta had a record attendance, about 18,000, maybe even higher. This time I thought it was pushing 17,000, but I think the official number was slightly below that. But the number of exhibitors was an all-time high. They had over 500 exhibitors. They had to actually open up another area in the convention center to accommodate them and provided some incentives for people to go there, but slightly fewer people, larger exhibit area, the conference sessions going strong as they always do. The floor looked a little bit thinner than it did before. But
A lot of the exhibitors are plumbing, right?
in
And
fact,
rather than software. So you've got
that's right.
physically large things that you're trying to exhibit, right? How to keep machines cool and all of that stuff. So I think that that may be driving the real estate of the floor plan, because you're not just a
I believe
startup
you're
with a piece
right.
of
Yeah.
software. Yeah.
Yeah. And also, these are industrial companies whose idea of an exhibit is a really large space. They're not thinking a 20 by 20. Like, they're generally used to having like half an acre. So the booths are really large. And of course, it's got massive pipes and refrigerators and, pumps and all. So there's a lot of that. And then there's a lot of cooling units. We talked about it last year. People like, Shell and Castrol and
You're going to redefine HPC as high power computing.
well, I wouldn't mind adding another power in there, but performance is a good thing. But you could see people like Shell and Valvoline and Castrol that you wouldn't see normally. So fluid mechanics and all these natural sciences are merging with electronics, and discussions of what happens when you immerse a wire into a fluid. In what way does it corrode? In what way does it so all of those become issues suddenly. And of course, if you're air cooling and you have a leak, it's okay. If you're liquid cooling and you have a leak, it can be a big deal. Okay, so that was SC25. No big news. There's a new top 500. Europe now has the first exascale system at the Jülich Center in Germany, and Europeans in general are proliferating supercomputers around Europe. They're sprinkling them about, so they're not as big, but they are numerous. And it's under the European Joint Undertaking Project, JU. And Jülich Center in Germany also starts with JU. So they kind of key off of that. And their system is called Jupiter, for example, and other things like that. In the US, it's really mostly driven by DOE. And we were talking in our pre-call, in part because of all the massive workloads that they need to run, managing energy issues and nuclear stockpile husbandry and all other things that they do. But they have a very vast area of science that they look at. And then RISC-V Summit. Couldn't go this time in person, but I attended a webinar that they had. So they're going strong as before. A lot of new action. Server companies that are doing RISC-V systems. Obviously, we know about TensorTorrent. Andes we talked to last year, Adrian, when you and I went in person. And there are several others. There's a company called Ahead that is doing some good stuff. So we expect RISC-V in mainstream of computing in short order, let's say. It's making its way, but it is benefiting from the road that ARM paved as it became bigger and bigger, starting from devices and going up. RISC-V is doing the same thing, starting in microcontrollers and then going up the stack. And then Q2B, Quantum to Business, is a conference that is put up by a company called QCware, a wonderful company with a really good culture, and they do a great job with this event. It started in Santa Clara. They expanded it to Tokyo and Paris. And then next year, it's going to be Chicago, Tokyo, and Copenhagen. I gave a talk there about quantum and HPC, as I have in previous years. They actually had an entire track on quantum and HPC, so I'm delighted that waving the HPC flag is being corroborated by everybody else, that HPC is indeed a very suitable first market and arguably a main market for quantum computing, at least in the short term. It's still not ready, but the vibes are becoming more and more towards applications and usage rather than just the technology. Now, Bob Suter, who's a well-known technologist and analyst in the field, he said that he'd calculated something like 84 quantum computing companies. And Bob Sorensen, who's another well-known and well-respected name in the industry analyst communities, said that that's bigger than all of the supercomputer and mini supercomputers that ever lived. So quantum computing is definitely a lot more prevalent these days than these other ones were in the past.
I read a headline today, and I won't embarrass the publication that put it there, but it was saying something to the effect that quantum computing is reaching its transistor moment. And I have my doubts and wonder how you felt.
No, it's not. We're far from transistor moment. We have like a half dozen modalities, as you mentioned also in the comment that I saw you wrote, that between superconducting, which is fast but it's noisy and it requires a lot of error correction, and trapped ions, which are high fidelity but they're slow, and then neutral atoms, which are good error correction, but also slow, because, for these guys, you have to physically move atoms and particles around and guide them with lasers, with like laser tweezers.
And by slow, we mean like 1 megahertz, right?
Very slow. Now, if you're a million times faster, then that slowness may still be okay. And, that leads into what is a quantum advantage. And for many people, it's not that you're necessarily exponentially faster than classical. It's that you're simply better in some way. Mm-hmm. And it could be better because you're better accuracy or less energy or indeed faster. Now, less energy is also an issue because if you need cryogenics and you need it for like 5 qubits, and now you will need 1 million qubits, the scaling of the refrigeration starts adding up. So Olivier Ezrati, who is another very well-respected name in the field, he had done some analysis of just how much energy it's going to require if you want to do quantum computing at scale, and it could be significant depending on the modality.
So have we reached the cat's whisker radio moment? That was the 1920s. Right? Basically a crystal and a bit of wire, you get a diode, which is enough to... So have we reached that moment? Have we got to get to that before we can get to transistors?
Well, we should come up with these milestones for quantum computing. There is such a thing as a cat qubit, however, which is better for error correcting because it sort of intentionally, if I understand it correctly, it sort of intentionally favors one kind of error than the other, because that one it can handle and the other one is harder to handle. But as a result, it ends up being better high fidelity. And then you've got many more, photonics and, topological, et cetera, et cetera. Go ahead.
Yeah.
Well, I was going to say in our pre-call, we also talked about the pace of innovation versus expectation. And that's a whole separate conversation. But I think that's worth thinking about and perhaps talking about in a future episode.
That is an important topic, and we should do it. So if you all agree, we can conclude this episode. Sound okay?
Yep.
Yeah.
Okay. Well, thank you, gentlemen. Thank you to our listeners. And until next time, take care.
That's it for this episode of the OrionX Download Podcast. Every episode is posted to orionx.net and shared on social media. Use the comments section or tweet us with any questions or proposed topics of discussion. If you like the show, rate, review, and share it. The OrionX Download Podcast is a production of OrionX. Thank you for listening.